MES College Marampally e-learning.
A very good morning to one and all. Myself, Jessina KU, Assistant Professor, Department of Computer Applications, MES College Marampally. Welcome everyone to my session. Today I am going to deal with the topic instruction formats and addressing modes of 8085 microprocessor. These are the topics included in the presentation. First, I will give you a brief introduction about how 8085 instructions are classified. Then I will explain about the different instruction formats and finally the addressing modes of 8085 microprocessor. Let us start with instruction classification. An instruction is a command given to the computer to perform a specific operation on a given data. Each instruction has two parts. Opcode or operation code is the first part of the instruction which specifies the operation to be performed. Operand is the second part of the instruction which specifies the data to be operated on. The data or operand given in the instruction may be in various forms such as 8-bit or 16-bit data, 8-bit or 16-bit address, a register operand or a memory operand. For example, consider the instruction MVI A,02 where MVI A is the opcode and 02 is the operand part of this instruction. 8085 instructions can be classified into 5 categories which include data transfer instructions, arithmetic instructions, logical instructions, branching instructions and machine control instructions. Data transfer instructions are used for transferring data from one location to another, where the first location is called source location and the second location is called the destination. These instructions simply copy the data from the source to the destination. The data transfer can be between registers or between register or memory location or between I/O device and accumulator, or an 8-bit data can be directly transferred to a register or memory location. The data in the source is not modified. Move, MVI, LDA, STA, LXI, etc. are some of the data transfer instructions available with 8085 microprocessor. Arithmetic instructions are used for performing arithmetic operations such as addition, subtraction, increment, decrement, etc. Examples of arithmetic instructions include add, sub, INR, DCR, etc. Logical instructions are used for performing logical operations such as logical AND, OR, XOR, rotate, compare, and complement operations. Some of the examples include ANA, ORA, XRA, CMP, RAL, etc. Branching instructions alter the sequence of program execution either conditionally or unconditionally. These instructions include jump instructions, subroutine call and return instructions, and restart instructions. And the examples include JMP, JC, JNC, JZ, call, return, etc. Machine control instructions control the operation of microprocessor. They control the machine operations such as interrupt, halt, etc. Some of the examples include push, pop, HLT, in, out, etc. Now we are moving on to instruction formats. We know that 8085 is an 8-bit microprocessor and hence it can handle 8-bit data at a time. In 8085, byte and word are synonyms, and instructions are referred to as bytes rather than words. 8085 instructions can be classified according to its size in bytes into 3 categories. They are 1-byte instructions, 2-byte instructions, and 3-byte instructions. 1-byte instructions include opcode and operand in the same byte. That is, only 1 byte or 8 bits is required for representing a 1-byte instructions. For example, consider the instructions move C, A, add B, HLT. All these are 1-byte instructions and hence only 1 byte is required for representing these instructions. Next is 2-byte instructions. In 2-byte instructions, first byte specifies the opcode and the second byte specifies the operand. The instructions MVI A, 32 and MVI B, F2 are 2-byte instructions where the first byte specifies the opcode and the second byte specifies the operand. Here, MVA and MVB are the opcode and 32 and F2 are the operand part of this instruction. The binary code of these instructions are given in the table. Next is 3-byte instructions. In 3-byte instructions, first byte specifies the opcode and second and third byte specify the operands. For example, the instructions LXIH, 2500 and LDA 3070 are 3-byte instructions. These instructions use the first byte to represent opcode and second and third byte to represent the 16-bit address given in the instruction. Binary code of these instructions are also specified in the table. Now we are moving on to the addressing modes of 8085. Each instruction requires certain data or operand to operate on. The format for specifying the operand of an instruction is called addressing mode. There are different types of addressing mode and they include direct addressing mode, register addressing mode, register indirect addressing mode, immediate mode and implicit mode. First one is direct addressing mode. In direct addressing mode, address of the operand is given in the instruction itself. Consider the instruction LDA 2500. The purpose of this instruction is to load accumulator with the content of the memory location specified by the address 2500. In this instruction, 2500 is the address of the memory location where the data is stored and it is given in the instruction itself. The next is register addressing mode. In register addressing mode, the operands are stored in the general purpose registers. Consider the instruction move A, B. It is a data transfer instruction which transfers the content of B register to accumulator. Here, A and B are the registers and operands are stored in these registers. Next is register indirect addressing mode. Here, the address of the operand is specified by a register pair. Consider the instruction move A, M. The purpose of this instruction is to move the content of memory location specified by the HL register pair to accumulator. Here, the address of the memory location is not directly given in the instruction. The address of the memory location is available in the HL register pair indirectly. The next is immediate addressing mode. Here, the operand is specified in the instruction itself. Consider the instruction MVA A,05. It is a data transfer instruction which moves the immediate data 05 to accumulator. Here 05 is the immediate data which is given directly in the instruction itself. The next is implicit addressing mode. In some instructions, there is no need to specify any operand along with the instruction. Examples are CMA, RAL, RAR. Here there is no explicit operand in these instructions. Here the operand is given in the accumulator. With this, I came to the end of my presentation. Thank you and have a nice day.